This graph, remember, was the smoking gun that linked chlorofluorocarbons to ozone depletion. So zooming in on this red line represents stratospheric chlorine. So that's stratospheric chlorine that comes from chlorofluorocarbons. And so this blue line represents stratospheric ozone. And so that's ozone in the stratosphere. So there are reactions between the chlorine that's in the stratosphere with ozone in the stratosphere. At this specific location on the globe, between 68 and 69 degrees south latitude, which is the South Pole or just over Antarctica, chlorofluorocarbons in the stratosphere over Antarctica are hit with UV energy and release chlorine atoms that are reactive. Those are the free radical chlorine, like this chlorine with a dot. That's one unpaired electron. Those very reactive chlorine atoms react with and cause ozone to be destroyed in reactions still up in the stratosphere. At the South Pole, chlorine, the presence of chlorine, causes ozone to deplete to the tune of about half. So the amount of ozone everywhere outside of the South Pole, everywhere outside of this location, is about 2,500 parts per billion. Because of the presence of chlorine, the ozone amount is about half, about 1,000 parts per billion. This report was put out in 1973. At the time, kind of a shock, because chlorofluorocarbons were not known to cause any dangers. They're used all over the place as refrigerants, as aerosols, as coolants, air conditioners, the refrigerator in everyone's homes. They all contained CFCs because they're non-toxic, they're not flammable, they're inexpensive, they're widely available. They revolutionized the air conditioning industry and in fact allowed for development of cities in hot places. The temperatures are too high for humans to live year-round. Air conditioning allowed for that. And even everyone having a refrigerator in your own home, that having cold food allows for development of societies so that people don't have to buy food every single day or have fresh food that goes bad. So though chlorofluorocarbons are non-toxic to humans, this study, this graph showed that these compounds were toxic to the ozone layer. Remember, we need that ozone layer, not just humans, but all of Earth. All of Earth is protected from UV energy coming from the sun. That ozone absorbs UV energy. It absorbs the highest versions, the UVC and the UVB, so that UV energy does not reach Earth. So without the ozone layer, we would have UVB and UVC reaching Earth, and it would lead to molecules being hit with UV energy, bonds being broken, and for humans, more incidences of skin cancer. So once the world understood the role of chlorofluorocarbons in ozone depletion, the response was amazing. Scientists, governments, and industry, they all worked together to stop producing chlorofluorocarbons and stop using chlorofluorocarbons. These chlorofluorocarbons are gases that are in the air, they're in the atmosphere that the entire Earth shares. And so because we all share this atmosphere, but we also produce and use those same chlorofluorocarbons, it was basically everybody has to stop using it. And this means every person, every government, every country in the world, because we produce it, we put it into the shared resource, well, then we got to stop producing it and stop putting it into our shared atmosphere. This led to what was called the Montreal Protocol, signed in 1987 by almost 200 countries, which was just about every country in the world in 1987. All these countries signed a treaty to ban the use and the production of chlorofluorocarbons in order to save the ozone layer. So that was only about 15 years after that first graph, that smoking gun, after that first reporting. In this time, there was a quick response of scientists to develop replacements for those chlorofluorocarbons, because refrigerants, air conditioners, coolants, aerosols, they're still needed and they're still in use, and scientists were able to produce substitutes that were not going to harm the ozone layer. It also required governments to get on board, to sign the treaty and to make laws that banned the use and the production of chlorofluorocarbons in their own countries. And then industries also had to produce new products using the substitutes that science provided for chlorofluorocarbons. This is actually the opposite of the tragedy of the commons. Remember when you have a shared resource that no one individual is responsible for? Well, here, no one individual was responsible, but the whole world was responsible and the whole world responded. And so the world took this seriously and they took responsibility. And the ozone hole has largely been repaired. Once the chlorofluorocarbons were gone, and you can see the amount, the thousands of tons of chlorofluorocarbons produced went to zero. Once they're no longer produced, no more chlorofluorocarbons are released into the atmosphere, no more chlorines are in the stratosphere, and there's no more ozone destruction going on. The seasonal thinning of ozone happens every year, and it has been noted in the last several decades that the thinning is not as thin, or that the ozone hole is not as much of a hole. It has recovered. In 2019, it was the smallest hole on record since the 80s. There is some data showing the ozone hole growing. In fact, in 2020, it was larger, perhaps due to climate change and the warming of Antarctica. But overall, in the last several decades, it's been recognized that the seasonal thinning of ozone is not a problem, or that the ozone hole is recovered compared to what it would have been, which is growing bigger and bigger and bigger and eventually spreading to the entire Earth, not having ozone protection.